involving the atmosphere is what we call thermal inversion. Now, thermal inversion is actually affected by air quality and meteorology. So air quality is dependent on the dynamics of the atmosphere, which are actually involved in the study of climate and weather, otherwise known as meteorology. So the study of the dynamics of the atmosphere is called meteorology. If you have an air parcel, now the air parcel, which is composed of the air coming from, let's say, an industrial plant or an engine of a vehicle. Okay. So that means this particular air parcel would have a certain temperature, correct? Let's say this is tau D, which means dry adiabatic. So in thermodynamics, you know what we mean with dry adiabatic. Okay. So if this is actually an air parcel, this is actually dependent on another temperature of the environment or of the surrounding, correct? So that, let's say that is your tau A or the ambient temperature. If the temperature of the air parcel is higher than that of the temperature of the environment, what would happen to the air? It will go up, right? Right? If the temperature of the air parcel is lower than that of the temperature outside, it will go down. So your air parcel keeps on going up and going down. Now, in a particular busy street, during peak hours, our objective is that this air parcel coming from your industrial plant or coming from your car should be what? Should be diffused to the air so as not to cause air pollution, correct? Now, what normally occurs is the phenomenon called thermal inversion. How does it work? Okay, consider the air parcel. If the air parcel, so you have to ground, the air parcel comes from any source, mobile or stationary, the air parcel will keep on moving up, correct? At what time? This will happen when? When the ground starts to emit heat. And normally this occurs during night. You learned this in physics, right? So if the ground starts to emit heat, that would mean the air parcel of the ambient or the air parcel would have a temperature lower than that of the atmosphere. So during night, there is what you call radiation thermal inversion. So the air parcel will keep on moving up, right? And then, when would it keep on moving down? When the sun strikes, during the day, it will break down the air parcel due to its temperature difference, and therefore, it will go down to us. That's how the air parcel moves. However, class, how many industrial plants do we have? We have too many. How many cars do we have? We have too many. And therefore, the concentration of the air parcel gets very, very high, and therefore it becomes too heavy. So even if you have the radiation thermal inversion that keeps the air parcel going up, because of its weight due to the air pollutants that would be encapsulated here, after some time, definitely you cannot extend the night, right? So the same length of time you have 24 hours. So during the sunset or the sunrise rather, that will now break down this air parcel and then will lead you back down or will lead the air parcel down. So what do you think would be the height difference if you would have lesser pollutants as inversion because as if you are creating a thick layer of pollutants. And this is actually known as inversion layer. So the thick cap actually prevents the air parcel to go up and to be fumigated. So what do we do? Do we do something about the number of industrial plants? Do we do something about the number of chemicals running and consuming and burning the engine? No. What do we do? We keep on adding the number. Therefore, we also make this heavier, and therefore we're also having the inversion layer thicker. So based from our discussion in the formation of the inversion layer, what is our objective with respect to our atmosphere? Do we want stable or unstable? We want it unstable. Why? Because the atmosphere, if it is unstable, it will help the air parcel to fumigate. So that's our concern. Now, how do you make the atmosphere unstable? Again, as I told you, it has something to do with the difference between the temperature of the ambient flux rates, which refers to the temperature of the environment, and then the dry adiabatic flux rate, which refers to the temperature of your air parcel. The normal dry adiabatic flux rates is actually 10 degrees Celsius per kilometer in average, and at the troposphere it's about 6 degrees Celsius per kilometer in the troposphere. What does it mean? This is the rate of movement of the air parcel that would be generated from any source of pollutants. So the difference between the two will dictate whether the atmosphere is stable or unstable. I told you that the formation of this inversion layer will brought about some environmental adverse consequences. So consider the formation of the cup. If the inversion cup will keep on accumulating and will keep on increasing its thickness, after some time, the cup may be broken. So if this cup is broken for any of several reasons, such as convection of any moisture present, these will erupt into thunderstorms. So that would also tell you why we have formation of strong typhoons, more frequent strong hurricanes, and more frequent tornadoes. Because temperature inversion or thermal inversion can notoriously result in freezing rain in cold climates. So normally this happens in cold climates. The figure in the slide shows you a smog, which is actually considered already as an inversion layer because of its significant thickness seen in the photo. So the rising smoke forms a ceiling over the valley due to a temperature inversion. This was taken when it's not a dew, but rather it's not a fog, but it's a smog, because this was taken on an afternoon in January. And January in this area is cold. So normally the temperature inversion occurs in a cold weather. But take note, class, that this is being enhanced further by the presence of the valley. Now, going back to our example, some of the industrial plants are actually located in urban areas wherein you have also high-rise buildings. So the high-rise buildings would also prevent the fumigation of the air parcel. So presence also of geographical features such as valleys and mountain ranges would also cause thermal inversion. Just like this. This may look good for a photographer, but not for an environmentalist. Because this is an example of a thermal inversion. Also this one. This is an example of a thermal thermal inversion. Take note that these pictures were not taken in the morning, but these were taken in the afternoon during cold period or cold season. These are further examples of thermal inversion photographs. This figure shows you the process of thermal inversion. The first figure shows you the normal condition wherein, as mentioned before, our objective is for the air parcel to fumigate. However, for the second condition wherein thermal inversion occurs and formation of inversion layer occurs, the pollution will be trapped. So the more pollutants we have, the thicker the inversion layer, the more the pollutants would be fumigated near us. So the different impacts of the pollutants that we have discussed would be more, we will be more susceptible to the impacts of this criteria pollution. Aside from being susceptible to the impacts or health impacts of the criteria pollutants, thermal inversion also causes another phenomenon that we are fearing of. These are the El Nino and La Nina. Again, just like global warming and stratospheric depletion, ozone depletion, El Nino and La Nina technically happen or occur normally. It's a normal process. So, for us to understand the impacts of the pollutants, let's discuss first how a normal El Nino phenomenon and a La Nina phenomenon occur. So, based from studies, El Nino occurs at the equatorial region. That's the reason why it's called El Nino, because El Nino means, it's a Spanish term which refers to little boy. And it originated from Peru. So Peru is somewhere near the equator region. So if this is your globe, okay? So your equator, you know the temperature difference here, the temperature here is so high. And you also know that the globe moves, and as it moves, it affects the direction of the wind, right? So, given these conditions, if there is an air parcel that catches, let's say, a breeze coming from the Pacific Ocean, what will happen is that this air parcel will start to make some parts of the water evaporate. That is again due to the movement of the air, of the earth, that brings about the movement of the wind. So the air parcel will be brought up slowly together with some of the parts of this water, body of water. So since it's hot, the rate of evaporation is also high, right? So most of the waters here will start to evaporate at a significant rate. And therefore, since evaporation occurs, what will happen is that the next process in the hydrologic cycle is condensation followed by precipitation. And therefore, what will happen is at the other side of the earth, rain will happen or will occur. So, if one side is experiencing El Nino, it follows that the other side of the earth is having La Nina. La Nina means little girl, so it's the opposite of little boy. So if it is evaporating here at a higher rate, this will be precipitating also at a higher rate. But what is the connection of thermal inversion? Remember, we said that thermal inversion accumulates a cap, which is composed of the thick layer of pollutants. So what will happen is, since it keeps on accumulating, the rate is the same. However, since it's fast, automatically the rate of precipitation, condensation and precipitation will also occur fast, right? So instead of traveling, just like the air parcel that we discussed a while ago, coming from industrial sources and mobile sources, instead of it to be fumigated at a higher height, it will now be fumigated somewhere here. So what will happen is instead of the La Nina to occur on a farther distance from where the El Nino occurs, it will now occur at a shorter distance. Follow? That would explain why sometimes you come from Las Piñas and it's raining heavy, then you go to Manila, you alight your bus at Manila City Hall and it's too dry. It's even too hot here. And now, it's getting worse. Why? Sometimes, within Manila, in Sampaloc, it's raining heavily, but here in Manila City Hall, it's too dry. And if you keep on accumulating the inversion layer, what will happen is that on the other street, it's raining, but here, it's so dry. So that's the adverse El Nino and La Nina effects. Another consequence of thermal inversion is what we have mentioned a while ago. These refer to the frequently occurrence of tornadoes, typhoons, and hurricanes. These are not only occurring more frequently, but the strength of these phenomena are great. So great that it even takes some of our properties, and worse, it takes some of our lives, or some lives of humans. So how does it occur with relation to thermal inversion? Okay. You know that a low pressure area would occur due to the complete normal movement of air, or the earth rotates. As the earth rotates, you have different types of winds. So if the low pressure area is to be formed, it moves this way, as shown in the figure. So the low pressure area is actually formed at this part. Okay? Now, on the contrary, the high pressure area moves the other way around. Okay. So imagine that you have a low pressure area passing through an air parcel. Let's say, just like what we had discussed in the Pacific region, where El Nino and La Nina may occur. Okay. So at this portion, certain phenomena such as ocean upwelling would occur. How does it work? If the low pressure area passes through this air parcel and it keeps on moving so as to form its strength, that makes the low pressure area very big. Could you imagine? So in that case, your low pressure area doesn't just contain water, but would also contain the air pollutants. That would make the eye of the typhoon and body of the typhoon larger. That is if it passes through the wet area. But normally on the other part of the region, you have the dry formation of cyclones, right? So minus the water, it works the same, but it passes through a thermal inversion layer, therefore it will also collect the air pollutants in the inversion layer to make the hurricane or the cyclone or the tornado even bigger. Okay, another consequence of thermal inversion are the accidents happening in the seas or in the oceans, wherein there would be some collisions of the ships. So you would notice there are no traffic jam in the oceans as well as Pacific or seas. But why is it that they collide? They collide because of thermal inversion. The thermal inversion causes the index of refraction of air to decrease as the temperature of the air increases. So in this case, or in this condition, what happens is that hotter air are being less dense, results in distant object being shortened vertically, and then an effect that is easy to see at sunset, where the sun is squished into an oval. So this leads to the formation of what we call Fata Morgana. Are you familiar with this? Or mirage. So what would be the impact of this Fata Morgana or mirage? This would have an optical effect in the vision of the captain running the ship. So for example, as mentioned in the previous slide, what will happen is, it seems that the ship is actually here, but since there is a distortion of the image, it is actually here. So you know that some nautical signs are being given to the other ship when they are near each other. So because of the vision, the optical effect, the captain may give some nautical sign which is not in conjunction with the actual location of the ship, and that may cause accident or collision. As engineers, and based from what we have discussed about the impacts, we can predict atmospheric stability. And by this, you can do something about the industrial processes, such as the emissions or the processes that affects the emissions of these pollutants. So we now discuss atmospheric stability. So our objective, as we have discussed, is to make the atmosphere unstable. And how would you know that it is unstable? You can vary the mixing depth. So what's the mixing depth? It's the altitude of the top of that mixed layer, or sometimes it's also known as mixing height. So for example, in any industrial plant, you have the industrial stock. The normal stock is 300, or the standard stock is 300 meters. So you cannot, since it's standard, because before, the reason why it has been made standard was the higher the depth or the higher the height, definitely the higher the fumigation, the better. So if the DNR representative would go and have a sampling on your stock height, what will happen is, if the higher it is, the lesser the concentration. That's the reason why they set a standard, which is about 300 meter. So since they could no longer, engineers can no longer vary the height, what they vary is what? The temperature of the blower. Because you know that if they make the temperature hotter, the faster the rate of the evaporation or the movement of the air parcel. That's also one way of dealing with your air emissions. But do you think it's sustainable? No, because making the blower hotter means higher energy consumption. So that would give you additional concentration of the emission. So how would you know that you're already reaching the capacity or the maximum standard set for the emissions? You can make use of your engineering skills, mathematical computations. So you can compute for ventilation coefficient. What is ventilation coefficient? It's the product of the mixing depth and the average wind speed within the mixing depth. So if the ventilation coefficient, which is in square meter per second, is less than 6,000 square meter per second, this is an indicative of high pollution potential. So you vary either the height, but there's a standard, and then you vary the speed, the flow rate of the emission. So you have to maintain what? Higher than 6,000. So as to initiate fumigation. Now, when you fumigate, you can make use of your parameters, your meteorological parameters, and that will tell you what kind of plume you're going to produce. Now, this figure shows you the variation of the height as well as the variation of the temperature with also respect to the wind speed. So these are the parameters that you can vary in your industrial process. Which do you think among the plume is the best plume? So as to initiate fumigation of your emission. Take note, class, the fumigation has to be done on the upper portion of the atmosphere, not on the lower ground. What do you think? The best one would be what? Loafing, fanning, fumigation, looping, definitely not looping. Coning is not possible because it keeps on increasing here, so it will go downwind. So I think the most stable would be loafing. As a matter of fact, loafing is defined as this. So when the stack is above an inversion layer mixing in the upward direction uninhibited, the downward motion is greatly restricted by the inversion's stable air. So we would like to hamper the downwind flow of the fumigation so as to keep the troposphere away from the fumigation of the pollutants. So loafing is the best code. So again, you can vary the different parameters, namely height, temperature of the air parcel, as well as the wind speed. There are two kinds of acid deposition. You may have wet deposition or dry deposition. If it is dry deposition, the SOx as well as NOx will be reacted with what? Particulate matter. So this particulate matter will just go down to the either to the aquatic system or to the lithosphere that may bring about acid deposition. Now, if it is reacted with water in the atmosphere, and then it will be going to the water or land through precipitation, this type of deposition is called wet deposition. Now, what are the impacts of acid deposition, whether it's wet or dry deposition? So, the soil will be more acidic. So, what is it to us if it is more acidic? Of course, the plants will not thrive. The microorganisms that will bring the decomposition wherein you get the nutrients will also be affected. And this is the worst part of the soil. Heavy metals would tend to be more mobile in an acidic condition. What do we mean? Let's say you have plants. So you have roots. Technically, if the soil will contain some of the nutrients such as calcium, zinc, manganese, etc. But if your soil is contaminated with heavy metals such as lead, copper, cadmium, aluminum, the acidity of the soil, if it is acidic, will make these heavy metals more mobile, and then they will be entrapped by the roots faster as compared to the normal nutrients. So that's one of the worst effects. What would happen? The plant will get contaminated, and the problem with heavy metals is that they bioaccumulate. What do you mean with bioaccumulate? As you go from one rank or trophic level in the food chain to a higher, the concentration gets higher. That's bioaccumulation. It also biomagnifies. What do you mean with biomagnification? As it moves from one trophic level to another, the intensity also becomes higher. What do you mean with that? If the plant gets contaminated with the heavy metal, no problem with the plant. Nothing wrong will happen to the plant. But if the plant will be eaten by the cow will get contaminated with the heavy metal, there's still no higher impact. But if the cow is turned into a corned beef or a hamburger, and it will be eaten by humans like us, that is where the impact would be higher. So that is called biomagnification. Now, worst scenario is that some of these would have specific effect. The aluminum concentration at higher, or if it's higher, and you get contaminated with it, that is related to Alzheimer's disease, even at an early age. Okay, another impact of acid deposition would be sulfation. What is sulfation? Take a look at the reaction mechanism. Your buildings, which are actually made up of limestone, will be slowly converted to calcium sulfate because of the presence of acid. You all know that the characteristics of limestone, if you continuously expose it in water, no problem. It will not be decomposed. But if the water is slightly acidic, that is, if you have SOX in water, what will happen is that this mechanism will slowly occur. So what is it to us? Calcium carbonate is relatively more strong than calcium sulfate. Calcium sulfate is just gypsum. So what normally happens is that the structures, without us knowing, due to acid rain, is slowly converted into a less stable and less strong materials. That's why you will just be surprised that a strong railway or a strong bridge would just collapse. That is due to acid rain. And that process is called sulfation. Conversion of calcium carbonate to calcium sulfate. Of course, you know the effect of corrosion brought about by acid rain.